Let's review by doing this class opener right here. True or false? If you graph the lines of each equation in a system and the lines are parallel, then you know that there is no solution to the system. True or false?
True.
True, that's right, it's true. Okay, so number one, true, right? Put a T right there for number one. Okay, number two, it's impossible to have more than one solution to a system of equations. False, right? It's not impossible. You could have an infinite amount of solutions if you end up with the same line, right? Number three, solve the following system by graphing. Okay, so we have this top equation and we have this bottom equation, but they're not ready to graph. If they want us to graph, let's rewrite them in slope-intercept form. So we're going to take that top equation and we're going to add 2x. So we're going to have a new equation that says y equals, if you add 2x to the right side, you have a 2x plus 3. You can't really add 2x and 3, so you just rewrite it, 2x plus 3. The bottom equation, we're going to have to subtract x. We're going to have 2y equals negative x minus 4. And then we're going to rewrite it by dividing everything by 2. Now remember, there's an invisible 1 right here in front of the x. So when you divide everything by 2, you're going to get the final slope-intercept form equation, y equals negative 1/2 x minus 2. Does everybody agree? Yes, I agree. Okay, thank you. So we have the red equation and the blue equation. Let's graph both of them with those colors so we could clearly see which one's representing which. So the red one crosses the y-axis where? The red one. 3, that's right. You start with the b value, that's at 3. What do I do from that point? Do I go up or do I go down? I go up because the slope is positive. So I need to go up 2 over 1. And I am at the edge. So far I only have this line right here. If I want to extend it, I need to use that slope pattern, but backwards. So maybe instead of going up 1 over 2, let's go backwards, over 1, down 2, over 1, down 2. And put a dot right here, and over 1, down 2, over 1, down 2. And you can make the line as long as you want. So we have this line right here, going through those points. And let's do the blue line now. The blue line crosses where? Negative 2. Crosses at negative 2 down here. Okay, now from that point, what do I do? What do I do from here? Do I go up or do I go down, depending on my slope? Down. Why? Because up here it says negative 1/2, so I'm going down 1 over 2. I want to put a dot right there. And of course, I could continue going down 1 over 2 this way, but I really want to go the other way, so I want to go the opposite pattern, or the pattern but backwards. Instead of going down 1 over 2, I want to go over 2 up 1, over 2 up 1. And we'll see that we end up right at that same point right there. And I could keep going over 2 up 1 to extend it as far as I need to extend it. But the main point is that I understand that the point of intersection is right there, and that point of intersection is the solution. What's the solution? Negative 2, negative 1. What does that really mean? That x equals negative 2 and that y equals negative 1. Those are the only two numbers, the negative 2 and the negative 1, those are the only two numbers that if I plug in for x and y will give me a true statement up here, and if I plug in for x and y it'll give me a true statement down here. Of course, we're supposed to double check, but because we're on a video and we're timed, we're moving on. So notes on solving a system via elimination method, aka linear combinations method. Okay, so I've seen different math books call it different things. Elimination method is one, because the goal is to eliminate a variable, okay? And it's also called linear combinations because how do we eliminate a variable? We combine the lines, okay? So different books have different titles to this method. I want to put both of them on there. Okay, so elimination method, what is it? The goal is to combine the lines to get a variable to cancel. So I either want the x's to cancel or the y's. Now sometimes both of them cancel, but we'll talk about that special case later. I want either the x's or the y's to cancel, okay? So you want it to cancel, that way you could create a new equation that has only one variable, okay, which you could solve and then plug in to find your others. So the steps. Step 1 is to modify one or both equations. Now, I didn't say modify right here, it says multiply one or both equations to get a variable to cancel. So let me just read that first step. I already read it, and let me do that first step right here, and you guys just follow along and watch me do it, and let me know If you guys are stuck, raise your hand, I'll stop. So it says multiply one or both equations to get a variable to cancel. So my question is this. If I look at this system, if I were to combine these lines, the 3x with the negative 4x, if I were to combine them, do they cancel out? No, I end up with a negative 1x. If I do 3x minus 4x, I end up with a negative 1x, right? Let me actually show that. If I were to combine them, the 3x and the negative 4x, I get negative 1x. It does not cancel out. And if I combine these guys, it also does not cancel out. You end up with a positive 1y. So that did not work. My point is, step one is to multiply one or both equations to get a variable to cancel. So we need to understand that. How are we going to cancel out a variable? Well, if this is a 3x and I want it to cancel out, then this one has to be a negative 3x, right? Or if this is a negative 4x, I need this one to be what? Positive 4x. Does that make sense? Now the thing is, if I need this to become a positive 4x, could I go something times 3 to give me a positive 4x? It doesn't work, right? So how about the y's over here? I need this to either be a positive 7y or a negative 7y, or I need this to be a positive 6y. I need these guys to be opposite, at least the x's or the y's. That way when I combine them, they cancel out. Now, as you can see, the x's don't cancel out. So what I'm going to do is multiply both equations. I'm going to modify both equations. And I'm starting out with the hardest one that there is. That way, if you understand this, the rest of them will be easy. So the top equation, I want to cancel out x's. All right, now you could cancel out y's, but I would rather work with a 3 and a negative 4 as opposed to a negative 6 and a 7. So I want to cancel out the x's. In order for me to cancel out x's, I need to change this to be a number, and I need to change this to be the exact number but opposite. So what could I change 3 to, and what could I change 4 to? Anybody? 12. Exactly. I need this 3x to become a 12x, and I need this negative 4x to become a negative 12x. So how am I going to change the top equation to have a positive 12x? Multiply everything by 4. So notice I put parentheses around the whole thing, and I put a 4 on the outside because I want to multiply everything by 4. Now what am I going to do to the bottom equation to get a negative 12 right here instead of a negative 4? Multiply everything by 3. So this is step one, guys. You got to modify one equation or both equations. Sometimes step one's already done for you. Sometimes it's ready to combine. But right here, I need to actually change both equations. That way on the top one, I'll get the 12x that I wanted. And on the bottom one, I'll get the negative 12x that I wanted. And then that positive and negative 12x will cancel out. But of course, I need to write the whole equation. So I need to go 4 times 3, that was 12x. 4 times negative 6, that's negative 24y. And 4 times 9 at the very end, that is 36. Everybody with me? Let's go for the blue one now. So I got 3 times negative 4, what's that? It's negative 12x. 3 times positive 7y, that's positive 21y. And 3 times negative 16, that's negative 48. Agree? Okay, so ladies and gentlemen, we have modified the system. I changed it. I mean, I didn't change it, I just made it look different, right? This equation's really the same thing as the original. This one's the same thing as the original. I just multiplied everything by 4 on the top, multiplied everything by 3 on the bottom, and that was step one. I needed to multiply both equations to get a variable to cancel. And now we're ready for the part which is called the linear combinations part, and also called the elimination part. So I'm able now to combine the lines. What is 12x take away 12x? 0 cancels out, so I just draw a line through it, it's gone. How about negative 24y plus 21y? What do I get when I combine those? Negative 3y. And then bring down the equal sign. And how about 36 take away 48? That's going to be a negative, anybody? 12. So do you guys see what just happened? I modified the top equation, modified the bottom equation. Why? So I could get the x's to disappear, to cancel out when I combine the lines. I combined the lines, the x's canceled. I now have a simple one-step equation, and I'll have one answer already. What's the answer going to be for y? It's going to be 4. And after. I'm just kidding. Horrible joke. So yeah, of course, you're going to have y equals 4. That's one answer. I need the other answer. How do I get the other answer? You plug it in. So which one would you like to plug it into, top or bottom? Top. And it doesn't matter which one. Okay, I would just choose the smaller numbers, I guess. It's a little easier. So 3x, take away 6y, but instead of y, I'm going to put the 4 right in there because y equals 4, equals 9. Okay, once again, I just copied this top equation right here, but instead of y, I put parentheses, and I plugged in the 4 right into the parentheses. And now let's work this out. We got 3x minus 24 equals 9. And of course, let's solve plus 24 plus 24. We're going to end up with 3x equals 33. And that means that x equals what? X equals 11. Ladies and gentlemen, we have found the answer to the system y equals 4, x equals 11. If you want to write it as an ordered pair, 11, 4. If you were to graph these equations on an xy plane, they would intersect at the coordinate 11, 4. Do you guys understand? Now that one was the hardest one, and if you still don't understand, that's fine. I mean, that was the first explanation, first example that I ever did of it. And you know what? I apologize because I never went back to refer to the steps. Step 1 was multiplying one or both equations to get a variable to cancel. That's your goal, to cancel out a letter, either x's or y's. Step 2, combine the lines. That's what I did right here. I combined the lines. And then I actually eliminated the x's. And I created a single variable equation, and I solved it, and I got one answer. And then after that, I mean, step 3, it comes naturally. Once you have one answer, you just substitute it back in. You plug it back in and solve. So let's go for one that we do together here. Now, sometimes it'll be ready to rock. What do I mean by that? Like sometimes you have a negative 4 down here. It'll just be there already, and you just combine the lines, and it cancels out, right? But in this case, it's not there. So you need to, just like on all math problems, you need to look at it and decide what's the quickest path. I want to get either an x to cancel out or a y to cancel out. So what do you guys think? Cancel out x's or y's? X's. Absolutely. Why? Because if I wanted to cancel out x's, what do I have to multiply the bottom equation by? Negative 4. And that's only modifying one equation. So notice the top equation, you don't have to do anything to it. You have a 4x, let's rewrite it, plus 3y equals negative 2. And the bottom equation became a negative 4x after multiplying everything by negative 4, minus 20y equals positive 36. And now we are ready to combine and cancel. Now, let's pause right there. Let's say you wanted to cancel out y's. I mean, you could do that if you want, but you'd have to modify both equations. You'd have to change this one to a positive 15y, and you'd have to change this one to a negative 15y. So it's a lot more work. So always take a look and see which one's easier to cancel out, x's or y's. Oh, in this case, x's are easier because all I have to do is multiply the bottom one by negative 4x, and the top one I could leave it like that, and now I could actually combine and eliminate, combine and cancel. My new equation will be negative 17y equals 34. Now that negative 17 kind of scares me, but when I divide by negative 17, what happens? Y equals negative 2. Boom, easy, nice answer. How do I find the other answer, guys? Plug it in. And into which one? Any one, right? Any equation you want. So it doesn't, I mean, and this both look easy. Which one do you want to plug it into? Second one? Sure, why not? The bottom one. It says x plus 5y, but instead of y, what am I going to put? Negative 2 equals negative 9. So I rewrote the equation. I plugged in negative 2. I really have x minus 10 equals negative 9. And if I add 10 to both sides, what do I get?
1.
X equals 1. Ladies and gentlemen, the answer to this system is 1, negative 2. And of course, you could double check. And if you're taking a test and you have time left over, go back and double check your answers. Plug in 1 for x, 2 for negative 2 for y, and see if it really does give you negative 2. Plug in 1 for x, negative 2 for y, and see if it really does give you a negative 9. It's that easy, guys. Let's continue practicing with the next one on the next video.